Hello, Introduction to Java Programming. In this session, we will discuss about classes and objects. As part of this class and objects, we'll discuss first specifying the class and the kinds of variables and how to specify a method and what is static, what is instance, what is local variable. All those details we'll discuss as part of part one. And in part two, we'll discuss about creating objects and the related stuff. Let's begin. Yeah. So what is a class? We understood class is actually a logical thing, which is not a physical one. It's kind of an abstraction. An example, a car is a class, a student is a class, an employee is a class. uh, when we speak of a class and we have to speak of an object, what is an object? Object is a physical entity, a physical one, which exists actually, so which has some state associated. So when I say car is my class, and then here I have to say my car. Okay, so my car has certain property. Let's say my car is in red color, my car actually model of 2022, and my car will give mileage of let's say some 25 kilometers per liter or something. Okay, so when we specify a car as a class, now you will have what is the color, the property, and then what is actually the model, and here what is actually the mileage. Okay, so it's an abstraction, it doesn't have values, where from the class you can create a number of objects, my car is red, your car is blue, somebody's car is white, etc and etc. So how do we specify a class in Java, and what are different types of data, and how to write a method in Java? Let's understand actually. A class usually treated as a two compartment thing actually. So that means the class is going to have two compartments. So let me actually annotate and tell you here. A class is represented. It's an object oriented programming. Uh, we have the class as the basis. And how do we get a class? So you need to understand some analysis and design. Okay, so when you design your class, you will see that there are two compartments. So the first compartment is about data. This is of data, and the second compartment is of methods actually. Okay, so of course, when data changes, some behavior is exhibited. So that behavior is actually methods. In programming terms, we can say this data is kind of variables, and methods are nothing but codes actually. Okay, so this is how generally a class is represented. Let me clear this and let me go take you to a few slides actually. Yeah. So what is a class? So class is a basis for Java language, because Java program is a collection of classes. So you have to write whatever you want to write in a class. Outside of the class, you can't have anything. If at all you want to write anything outside of the class, that is another class. Yeah. So each concept you wish to describe in Java must be included in a class. A class can be understood in a number of ways. Class is a blueprint. Class is a template of objects. Okay, and different examples actually. Uh, any abstraction like dog is actually class, and your dog is an object of it. Okay, and any class, whatever we define, becomes like a new data type. That's called abstract data type. That's a class type or a reference type. And when you know what is a class and we know what is an object, we can actually say an object is an instance of a class. Okay, so this is how we can actually understand about the class. And in Java, we have classes arranged in hierarchy. Okay, so Java defines the classes. Java has very big library. I told you a huge API, and which API is actually part combination of modules, and modules are divided into packages. Packages contain classes, interfaces, etc. and etc. So at the top of uh, uh, the hierarchy, we have a class that is called object class. Okay, so object class is the super class of all Java classes because it forms a hierarchy, a class hierarchy. Somebody should be at the top, right? So there is a class called object class, and the fully qualified name is java.lang.object because it's available in the Lang package. So, and we discussed actually there is a principle in object-oriented programming that's called inheritance, right? So a class can acquire properties of other class. So since object class is the root class and every other class acquires from this particular object class. So object class is the parent class for every other class. Okay, so object class in fact has 11 methods and those 11 methods can be used by subclasses. Okay, yeah. So let's actually understand the definitions, how to specify a class. Whenever you write a class, you should first of all have a class keyword. So out of the 53 keywords, class is the keyword. Of course, we know that we have written so many programs, and the class has a name. So a name is a valid identifier, and this class can contain several variable declarations. That is nothing but the data. As I told, a class contains data members and methods. So these variable declarations are actually nothing but the data, and they can be actually of two types. Okay, so they are called instance variables, and they are also called static variables. I will give one example to tell you that, and followed by the methods. Followed by the methods. Okay, a class, when you specify, you have to specify data and methods. But so far, whatever the programs we have written, we haven't specified any data. So we have actually used a main method and everything we are doing inside the main method. Okay, so now we are actually starting the object-oriented programming with Java, where we specify classes and we actually have the data defined and how the data is used by these methods. That we are going to actually see as part of OOP with Java, and we are going to create objects here onward. Okay, in fact, a class also contains some constructors, certain blocks, of course, some classes also that we will see as we progress. That means not just data members and methods, it is going to contain few things more also like constructors, static blocks, and nested classes, etc. And when you specify, you have to specify like this. So class followed by the class name, and this class can have certain visibility specifiers like a public, or not specifying means default specifier. And you can have a number of variables. Those can be instance variables or static variables or class variables. I will tell you in a moment. And you can actually have several methods defined actually. Okay, so with this, let me actually go and specify one class over here. Yeah, so I'm going to write a class student. So let me save this as a student.java. Yeah, so I'm going to write a student class actually, because student is a class, right? This student, that student, my student, your student, these are all the objects. Our student S1, student S2 are the objects, right? So student.java is the class which I'm going to write. So yeah, so class student, and then, so what a class contains? Data members and methods actually. So these are the two compartments, right? Now, what is the data? What a student causes actually? What are the properties that the student will have? So you are not actually creating an object, right? So you should not give the state, the values. Rather, you have to define a category, a class, a blueprint, a template for a student. So every student will have certain ID, right? Let's say that is SID. So when you speak of SID, what is its data type? Right? We have to specify the data type. So this is integer. So int SID, this is my one data member. And every student will have some name actually. So name is sname. Sname is actually of string because it's a sequence of characters. So we will say sname. And every student also will have certain GPA associated, CGPA or GPA, whatever it is. So let me take as a grade point average. This is a double value. So if you wish, you can also specify, so in which college is studying, in which university is studying actually. Okay, so let me actually have a string that represents the college or the university, right? So let me actually say university. Okay, So now these data members, right, SID, name, GPA, string university, now are all instance members. Now I can say these are instance members because these are all non-static. I have not specified any static actually over here. I have not specified any static. So SID is actually what kind of variable? This is an instance variable. Okay, basically it is a primitive variable because the type is integer, right? So it's a primitive and it's instance. And string is actually a reference type. It's a reference variable, and of course it's an instance because it's non-static. And GPA double is actually primitive type, right? So it's a primitive value. At the same time, it is actually instance variable. Okay, and university. So now this university, see, I'm actually modeling a student of an university, right? I'm modeling a student of university. So that means all the students belong to a particular university. So for that particular university, I'm actually writing an application, let's say student management system, right? So all the students, the university is same actually for that particular university. Let us assume we are actually writing a student management application for the students of an university. So now what happens for all the students, the university is common, right? So let's say the university is actually, yeah, so which university? So let's say we are actually modeling for a Stanford University. Okay, so string university Stanford. Okay, because it's common, I'm giving the name, right? Because all the students, Stanford is same. So now anything which is common to the whole class, we can actually make that as a static. So anything which is common to the whole of the class can be made as a static actually. Now SID, SNAME, GPA are different from a student to student, right? But all the students have University Stanford only because we are modeling application for that particular Stanford University, right? So anything which is common can be actually specified as static, and this is actually called a class variable. Okay, so that means in a class we have data members, and these data members can be of two types. They are non-static and static. Non-static data members are called instance members, and static data members are called class members. They're called class members. Okay, that's about the two types of things actually. And let me actually also tell you, all the instance members will be associated with an object. So these are also called as object variables, and all objects are going to be stored in a memory that is called heap memory. Okay, JVM uses some runtime memories. At least I need to tell you about three memories actually over here. So there is something called heap memory, and there is something called class area or method area. We can also call this as a method area. Okay, and there is something called stacks or stack area or heap area, heap area. So there are three methods, sorry, the three memories which are used by JVM for executing a Java program. So all objects are allocated in the heap actually. All objects are allocated in the heap. So all object variables, right? So all object variables or nothing but instance variables will be in the heap area. And all static variables are called class variables, and they will get allocated in a memory that is called class area or method area. Okay, so that's it. So in a class, you can actually define data. The data can be of two types, static and non-static. So non-static is actually instance members, which are object variables stored in the object. So the memory is heap. Non-static variables are separately stored in a class area because they are common to whole of the class. One value per the entire class, right? So yeah, so once you have data, you can actually specify methods. Okay, so why we have to write methods? Methods will actually act on this data. Otherwise, you don't require any method also. Whenever you have data, then only you require methods. So methods are nothing but behaviors. They will actually work on this particular data. Since I have data, at least I have this data members defined. I at least I need one method to set data for all of them actually. So I require one setter method. Okay, so in any class we will have setter methods and getter methods actually. So setter method sets the data, getter method gets the data. Okay, so what is setting and getting? Let's understand actually here. So now I'm going to write one method where this method is actually going to set the uh, student class actually. Why set the student? So here I have an SID, SNAME, GPA, right? So these are the instance members. Of course, my static variable is initialized. Now I need to set this data, that what is the SID value, what is SNAME value, what is GPA value, that I have to set through a method actually. So we understood a little bit of encapsulation. Uh, so encapsulation is tying data members with the methods. So in order to access this data, you need to have methods, right? So methods will operate or act on this data only through methods. That's what actually encapsulation. So I will tell you in a clear fashion as we progress. Now I want to set data for this one. So for that, what I'm doing is I'm taking some ID, int ID, that's a local variable, and I'm taking some string name. It's another local variable, and I'm taking some um, average, right? So this is actually let's say some average GPA or whatever it is. So now what I'm doing. So now these three are local variables. Yeah. So let me actually introduce another type of variable, that is a local variable. Okay. These are all local variables because they are as part of a method. Okay. So ID is a primitive variable. Name is a reference variable because it's of type string, right? Any class type is a reference variable. And average is a primitive variable, and all are defined inside a method. So that's why they are local variables. And all local variables will be there in a stack area. Okay, all local variables will be there in stack area because for each method a stack is going to get created. Okay, so these local variables, they are going to get assigned in a memory called a stack area. This is the runtime memory. Heap, class area, and stack areas are runtime memories used by JVM. So here what I'm doing, I have to set student actually. So with the local variable ID, I am actually setting my SID. So that means ID I am giving to my SID, and my SNAME is getting set with a local variable called name, and my GPA is actually getting set with some variable called average, grade point average. Fine. So this is actually setting this data. Okay, usually we'll have a setter for each data item, and then we need to have a getter also. So now I have a method called getStudent. The getStudent method, we will actually display student information. So how to display student information? Just a system.out.println and then display all the details actually, SID, then SNAME, then actually I have this particular GPA. So how I'm doing, SID I'm printing, giving a space over there, and then SNAME and giving a space, and GPA. That's it. This is my getter and this is my setter actually. Okay, so in any method, if you use any local variable, if you declare any variable, that is going to be a local variable, right? So when you specify a class, you will have three kinds of variable and only three kinds. The variables which are declared inside a class but outside of a method or a constructor can be instance or static. The variables which are declared inside a method or a constructor are local variables. Okay, let me actually show you over here in my slide actually. So there are three kinds of variables when you specify a class. So you have local variables. Of course, we know in any method, whatever we declare are local variables. Other than that, we have class and instance members. Right now, let's understand local variable. Of course, we know inside a method or a constructor, and instance variable inside a class but outside of a method or a constructor. A static variable with a static keyword, which is just like instance only, but it has a static keyword. That means that is declared inside a class but outside of a method or a constructor. Okay, so what is the usage and the lifetime? Local variable has a lifetime as long as the method is getting used actually. So when a method usually local variables to hold intermediate results. And when method is actually called, so you will have local variables and some computations and then done. Whereas an instance variable actually is an object variable, so it is associated with an object. As long as your object is active, as long as your object has a some reference, and your instance variable will be there, and objects are created dynamically at the runtime. So new keyword, we are going to use it. And class variable actually will be created when the class is loaded. Okay, so when the class is loaded, that means whenever your dot class file is ready and you want to execute that dot class file, so class has to be loaded, right? So during the loading time, the class variables will get initialized actually. Okay, of course, these are certain examples here. And the local variable must be initialized before use, because it's a local variable. It has to be initialized if at all you want to use. Whereas instance variables and class variables, they will get initialized to their default values. So that's why default value concept is important. Whenever it's instance member or a static member, you just declare it. They will get initialized to their default values. Okay, and of course, I spoke of memories already. Which memory? Local variables in the stack area, instance actually in the heap area, class or static variable is in the class area. Okay, so what's the scope and visibility? Its local variables are visible within the method only or in the constructor. Okay, so instance members can be seen by all methods. So in a class, you are specifying the methods. All methods can access those instance members, even though they are actually private. So within the class, they can be accessed. If they are public, they can be accessed from anywhere. Okay, same as instance variables. Static variables are same as instance variables, but they actually static variables. They are common variables across the whole class. Okay, so they will be treated finally as final static variables that are nothing but constants. Okay, so that is about the variables. So let me actually go back to my program here. Yeah, so here when I say SID, SNAME, and GPA, these are all instance variables, and university is actually I assigned Stanford. So now what happens, right? So all these values will have initially their default values assigned. So default value for int is 0, SID will be 0, SNAME is null, double is 0.0, and this university is also null because it's a string. Okay, so that's what default value assignment. For local variables, there will be no default values actually. You have to initialize them. Okay, so of course, these values we are passing from a method call, right? So now this is how we actually specify a class with a name. So you can actually give some visibility also. You can actually make it public, or otherwise you can leave it. So if you leave, it has a default scope. Okay, it is actually having a default otherwise specification, default specifier. So that is actually package level. The scope is up to a package. So we don't create any package. So the scope is within the folder where it is actually getting stored. So I have a folder package Java. So now scope is actually within the package. That means all other classes in that package can actually access the student. If you want to mention, you can actually mention as public. So public default, only these two are allowed. You cannot make private or protected. Okay. So these are the data members and these are the method members, and these method members usually will be public actually. Okay, because so methods are the means to access the data, right? So usually we will make them public. If you don't make public also, there is no problem. So they are accessible within the package. So when you go out of the package, then they can't be accessible. So let me make public, because methods are designed to be public, because methods are only the way to access this data generally in a class, because you want to restrict the access to you want to restrict the access to the data which is not there in the POP programs, but we can actually restrict. Of course, for that we have to specify a keyword called private. So I will actually discuss that. Okay, so now let me actually go and see what actually was so I initially thought of for discussing. So what is a class? How to specify, we understand, and types of data we have understood with the details. Now, what is an object? So since we have a class, can you create an object of it? Okay, since you have a class, can you create an object of it? How to create it? So all these things we have to discuss. The detailed discussion I will make actually in the next session. But since we have a class, so what I do is I will actually compile it, and I will show you a few details here. Since I have a class and saved as student.java, now actually what I can do is I can compile this Java C student.java. Yeah, it's compiled successfully. There is no issue. Okay, and you can actually see dot student dot class file getting generated here. So you can actually see somewhere here student dot class, this file got generated. So of course we know how to see the bytecodes also, right? How to see the bytecodes we know. So let me actually show you that also. Java P student. Now you can actually see the bytecode. So compiled from student.java, and this SID, then java.lang.string.name, double GPA, and java.string.university, and which is a static. And I told you, if I'm not writing any constructor, default compiler supplies a default constructor that I have seen earlier, right? So whenever we are saying the bytecodes, we understood this. If there is no constructor, a default constructor is supplied, and that is actually required to create an object. Okay, this part I will come actually in the next session. Okay, and here I have my set student and I have my get student. Since I'm using my static variable, I have a static block as well. Okay, so now can I run this? Can I run this class? No, right? So Java space student, Java space student. So I cannot run because there is no main method. You know, in order to make this as an application, you require a main method. Because when I say Java space student, the dot class file will get loaded initially. During that loading time itself, the static members will get allocated, and later main method is called actually. Student.main interpreter calls the main method and it start actually executing the main. But do you have the main method? No, you don't have a main method. So now what it says, main method not found in the class student, please define the main method as public static void main, right? But now I don't want to write the main method over here. So I want to keep my class as pure business class. The student class is my pure business class. Okay, so I want to create object of this class somewhere over here actually. Okay, so I have some class test. This class test is my main class. Because I have the main method, this is also called a driver class. Okay, so this is my main class. Otherwise, I can also call as a driver class because it drives the application, right? That means it starts actually from which it starts. So here what I'm doing is I would like to create object of the student. The student class, I want to create object of the student class and call these methods set student and get student. Okay, so now what I do here in my test class, because this test.java and student.java both are in the same package, they can access each other. So now I can actually create a student object here. So the syntax is like this. The syntax I will explain very clearly in the next session. Student S1 equal to new student. This is actually creating an object. This is actually creating an object. How I am creating, what is new, what is student, these all things I have to discuss. That's actually in the next session. But since I have the object created when which is referred by S1, now actually I can call the set student method. S1 dot set student, I need to set S1, so SID, that is 123, and the name is, let's say, ABC, and some GPA I have to set, let's say the GPA is 8.9. Okay, and I can actually get student also. I can call this get student method S1 dot get student. That's it. I have created an object and I'm calling all these methods which are there in that particular student. So let me actually show you that it will work. Yeah, so Java C test.java. So I have already student.class file. The bytecodes of students are already available. I just need to compile this test.java. It's compiled successfully, and when I run Java space test, now it looks for the student class. The dot class file is available. It creates an object. Then it calls the set student method. And when I say get student, it displays the data. Now you can see 123 ABC 8.9 is coming up. Okay, but there is a lot many things to understand over here, and that will be the part 2. So hope you have understood how to specify a class and what are different kinds of variables, okay, and how to specify methods like getter and setter, and the runtime memories, etc. In the coming session, we actually see how to create an object. Okay, what is an object? How to create an object, and what is a constructor? All these details are going to come in the session. Thank you.